Okay, so now we're going to just do a couple of these problems together for our Chapter 7 review, just to make sure we're on the same page here. So, again, this chapter is all about finding missing sides, missing angles in right triangles. And we have many techniques. So remember, if you are given 2 sides out of 3, you can always simply use, right, our good old friend, the Pythagorean Theorem. C squared equals a squared plus b squared. If you are given 1 side, but it's a special triangle, so it's a 45 or 30, 60, 90, you could use trigonometry, that's fine. Or it's often faster just to remember old 45, 45, 90, hypotenuse equals leg root 2, 30, 60, 90, hypotenuse equals shorty times 2, 30, 60, 90, long equals shorty root 3. Okay, it's easy enough to remember. Finally, if you were given 1 side, but it's an angle that's not special, like 41 degrees, 75 degrees, you can use our trig ratios, right? Trig ratios. So we can use the sine ratio, opposite to hypotenuse, if we have those. We can use the cosine ratio, the adjacent to hypotenuse ratio. Or we could use the tangent ratio, opposite over adjacent. Finally, if you know 2 sides, right, you know the ratio, but you're trying to find the missing angle. Notice that this is the reverse. Normally we know the angle, we're just trying to find the ratio. This time we know the ratio, we're trying to find the angle. You can use, right, sine inverse, right, sine inverse, cosine inverse, tangent inverse. And again, what it is, you look up the ratio to find the angle, right? It's the reverse normal. Okay, so this is pretty much a summary of the entire chapter. These are all the techniques we can use. These are to find sides. You can use the inverse ones to look up the missing angle. Okay, now I want to get to a little bit of a conceptual one. So once you read this and see if you can pause the video and see if you can figure this out. This was a homework question that most people didn't try, so I want to make sure you try this. Pause it, try it, and then unpause it and see if you were able to get it. Okay, so I want to draw an equilateral triangle, each side labeled 2x. Okay. So first off, oops, I guess I should have put this first. Show how to drive a 30, 60, 90 triangle from this. Well, remember, if this is equilateral, that implies that this is also equiangular. So we have 60 degrees, 60 degrees, 60 degrees, right? 60, 60, 60. And so thus, if we cut this in half, we get ourselves a nice 30, 60, 90 triangle. 30, 60, 90. Okay, so I'm just going to remove this so we can see it. Okay, so let's go ahead and label this. So if this is 2x, this would be x. So let's prove that the long leg equals the short leg root 3. So again, let's just call this y. Let's prove that this works. So I'm just going to do this as well. Let's prove this works. Let's just use the Pythagorean theorem to set it up. Let's say c squared, right, equals a squared plus b squared. And again, make sure you put this in parentheses, the entire thing squared. C squared equals a squared plus b squared. Okay, so I want to solve for this. I want to show that long equals shorty root 3. Okay, so what is 2x times 2x? Right? What is 2x times 2x? Not just 2x squared. It's 2 times 2. It's 4x squared equals x squared plus y squared. Okay? How do I isolate y? Okay, I need to get rid of this x squared, so I'm going to subtract x squared from both sides. So y squared equals 4x squared minus 1x squared. What's 4x squared minus 1x squared? That's 3x squared. 3x squared. Okay, and then square root both sides. And so we get, this just becomes y. Y equals the square root of 3 times the square root of x squared. Right? Square root of 3 times square root of x squared. This, I don't know how to simplify. This is not like a whole number or anything like that. Square root of x squared simply becomes square root of 3 times x. And so there it is. Y equals x root 3. So we have just shown that if this is 2x, shorty is half of that, that's 1x, and the long is shorty root 3. Okay? And then finally, show why cosine 60 degrees is always 0.5. All right, so let's just redraw that triangle here. So we have 2x, x, and x root 3. Here's my 60 degrees. Okay, so show why cosine 60 degrees is always. Well, what's the cosine ratio? Cosine 60 degrees. Again, notice that this is for x. This works for any triangle, whether this is size 1 or size 2 or size 5 or size 1,000,000. This is always going to be double. This is always going to be root 3. So let's just think. This is the adjacent over hypotenuse, right? So this is our opposite. This is our adjacent. This is our hypotenuse. So cosine is not the opposite. It's the adjacent over the hypotenuse. So it's just equal to x over 2x. Well, what is anything over double that thing? You can just cross this out. That becomes 1 over 2. Just 0.5. Right? It's just a 1. So cosine 60 degrees is always 1/2, no matter how big or how small, right? Because you're comparing shorty to hypotenuse, right? You're comparing shorty to hypotenuse. This is always half of that. Okay, so this next page. So again, we've learned a lot of different techniques. I'm not going to tell you which technique to use. Think about, should I use Pythagorean? Should I use these guys? Use these if you can. Otherwise, use your trig ratios. If you're finding missing angles, use the inverse trig ratios. So try these problems here to solve for x and or y. I want to skip ahead, though, to just do a couple more examples here of solving the triangle. Solving the triangle. So again, solving the triangle means to find right, all sides, all angles. All sides and all angles. So we have to look to see what we have here. We'll do number 8 and number 9 together. So on this problem, I've got two sides. So I could find this, I'll call this x. I could find this by using the Pythagorean Theorem. So let's set that up. C squared equals a squared plus b squared. Okay, my hypotenuse is the longest side, that's 10. 10 squared equals x squared plus, and you can punch this in your calculator, but I'm going to try and leave it as a root, try and make sure I do this accurately. 5 root 2 squared. So this is 10 times 10, this is 100. Oh, 5 root 2 squared. What was that again? Let me just write that out. 5 root 2 times itself. 5 root 2 times 5 root 2. Let's see. 5 times 5 is 25. What's the square root of 2 times the square root of 2? That's the square root of 4, or just 2. So 25 times 2 gives me 50. Okay, so this is 50. Okay, well, we're going to solve for x squared, so I'm going to subtract 50 from both sides. So it's 0, so x squared equals 50. Okay, so we get, if we square root this, x equals the square root of 50. Now if I try to simplify, let's take that. 50 breaks down into 5 times 10. 10 is 5 times 2. So it looks like I have a repeated pair. So this looks like there is a perfect square, right? It's 25 is the factor. 5 times 5 times 2. So I can take this out. Square root of 25 really is just 5. So this becomes 5 root 2. Interesting. So this is 5 root 2. And this is 5 root 2. Okay, so I've got all the sides, 5 root 2, 5 root 2, and 10. Let's find the angle. So you might have already thought of how to find one of these angles, but let's pretend I haven't noticed anything yet. Let's find angle B. How do I find angle B? Well, I don't have any, I can't use a triangle angle sum theorem because I don't know angle A either, so let's use our inverse trig ratios. Again, you can pick, I have all three sides, so I could pick any of them. I could just do, let's see, if this is my opposite and this is my adjacent, right, I could use the hypotenuse, but since these are the same, that looks a little bit easier. So that's opposite over adjacent, that's the tan ratio, right? So let's just call this B. So tan B, right, tangent ratio at angle B is equal to 5 root 2 opposite over 5 root 2 adjacent. Well, anything over itself, I could just rewrite that as tan B equals 1. So I just have to ask myself, what angle has a tan ratio of 1? Maybe I know it off the top of my head. Otherwise, I could just type it in. Tan inverse of 1 equals b. Again, this is what it means to be an inverse, right? Normally, we say, given this angle, what's the ratio? This is saying, given this ratio, who's the angle that produces that ratio? Right? Who's the angle that has a 1-to-1 ratio? So I just type tan inverse of 1, and I remember, oh yeah, it's a 45, 45, 90. So b is equal to 40, or I should say measure of angle b is equal to 45 degrees. And once I've got this is 45, there's no need to do another inverse trig ratio here. You can just do 180 minus 90 minus 45, or we just know that the measure of angle A is also 45 degrees. Okay, so that's it. We solved it. We've got 3 sides, we've got 3 angles. Done. Okay, so when these types of problems, when you have 2 of the sides, you probably use the Pythagorean theorem to find the third, and then use your inverse trig ratios to find another one. For this one, this time, I've got one angle. This is 19 degrees. I only have one side, though, so the Pythagorean theorem is out. It's not like this one. So what I can do, though, is I could find this angle fairly easily. I don't need to use an inverse trig ratio. In fact, I can't because I only have one side. But what I can do is I could just say, hey, this is 180 minus 90 minus 19, right? So I can just take 180 minus 90 minus 19, or just 90 minus 19, and that's going to be, what, 71 degrees. So the measure of angle D is 71 degrees, right? 71 plus 19 is 81, 90, yep, plus 90 is 180. So when you already have 2 angles, you don't need to do the inverse trig ratios here. You could just say triangle angle sum theorem, find it. Okay, so now I have a problem. I need 2 of the sides. So I still can't use Pythagorean theorem. I don't have 45, 45, 90. So I'm just going to call this y, call this x. Let's use, let's see, what method do we have? Okay, again, this is still out. I don't have this. I need to use my regular old trig ratios. Okay, so let's go ahead and label. This is the guy that I want to use. Let's find y first. So this is my opposite. This is my adjacent, OA. So it looks like I'm going to use the tangent ratio. So tangent ratio. So tangent ratio at 19 degrees equals opposite over hypotenuse. And so I just multiply both sides by 11. 11 over 11 makes 1. And so we've got our answer. Y is equal to 11 times the tangent ratio at 19 degrees. 11 times the tangent ratio at 19 degrees. .79, approximately 3.79. Okay, so if we try to smell that number, this is 11, so that seems kind of off, but look, this is so much smaller. This is 11, this being 3.79 actually doesn't seem that bad. Okay, to find x, we have a couple choices now. We could either use the Pythagorean theorem, a squared plus b squared equals c squared, or we could just use a different trig ratio. I'm just going to use a different trig ratio. So I'm going to say, all right, what do I have here? This is my adjacent as 11, and this is my hypotenuse. Adjacent over hypotenuse, that's my cosine ratio. Cosine ratio. So cosine ratio at 19 degrees equals AH, adjacent over hypotenuse. So adjacent is 11, hypotenuse is x. And again, you could have used Pythagorean theorem. You could have even used 3.79 for this, and you could have used, for example, the sine ratio. That's fine as well. But I'm going to pick this 11 because that's a little bit easier to work with. Remember, x is underneath, so I can't multiply by 11. That wouldn't do anything. That would just give you 121 up here, 11 times 11. I'm going to multiply both sides by x. So I get x times the cosine ratio at 19 degrees equals 11. And so to finish off, remember cosine ratio at 19 degrees is just a ratio, it's just a number. If you punched in to round it, it's about 0.95, right? So you just don't divide by 19, you're dividing by the cosine ratio at 19 degrees, which is about 0.95. So let's just divide both sides by 0.95. Right? Divide both sides by 0.95. In other words, divide both sides by the cosine ratio at 19 degrees. Okay, so our final answer, x equals 11 over the cosine ratio at 19 degrees. And what is that exactly? 11 over the cosine ratio at 19 degrees. about 11.63. Okay, so that makes pretty good sense because again, this is 11, this is bigger, but not by much because this is a really small angle. So this is almost as big as this, right? It's 95%. Remember that cosine ratio is about 95%. This is 95% as big as this. So this is 11.63 is a little bit bigger. Okay, so you can see there's different types of ways to solve. Think of all the methods. Do I need to use inverse trig ratio? Can I use the triangle angle sum theorem, Pythagorean theorem, regular SOHCAHTOA? So try this one, this one, this one, and this one. And then finally, number 14. This is like a conceptual problem. Think about what would happen if you had a right triangle. Start off as 45 degrees and then gradually got smaller and smaller and smaller with the opposite side staying the same. Again, check out this Google link here. Put it at 45. You'll have a triangle ABC, put it at 45, and then just kind of see if you can figure out, you can click the sine, cosine, tangent. Think about this side to this side. As I shrink this guy this way, what's happening? If this stays the same, what's happening to the ratio? What's happening to the ratio? Okay, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Will they stay the same? Will they get bigger? Will they get larger? Think about who's on top, who's on the bottom, which one's changing, and how is it changing? Okay, so think about that problem. And then finally, so that's your classwork. It's going to be worth points. And then our homework is this guy right here. Oops, no, not this guy right here. This guy right here. So it's a little bit longer, but you have a little bit longer. First page, I would like you just to understand again that sometimes there's multiple methods possible. So solve for this hypotenuse length AB, you can call it X if you want. Solve for this length AB using 4 different methods, including 2 different trig ratios. They should all lead to the same answer. Okay, so one way to look at it, since I have 2 numbers and I just want to find the third, what method could you do? Method 2, since I have a 30, 60, 90 special triangle, let's just think. 30, 60, 90, who am I finding? That's my hypotenuse. Hypotenuse equals shorty times 2. Right, who's my shorty? Right, that's this guy. So x equals 1.72 times 2. Right, 1.72 times 2. Or 3.44. So you should be getting pretty much 3.44 for this and for this as well. Okay, so you can use this particular one because I've given you a nice 30-degree angle and I've given 2 of the sides, 4 different methods open up. So see if you can get 3.44 for these other 3. The rest of your homework is just a review, again, about all the different methods we could do. This is all just about sides. There's no angles, I believe, in here. But try them out. And then the solutions are posted on the back. But try them, of course. Show your work. And then you'll be good to go. So go ahead and finish up the classwork first. And then you can work on this, this homework. Okay?